In this demo, this is what the Hedvig installation looks like, in which there are 6 nodes, and 3 of them are in on-prem, and 3 of them are in Azure. And as you see, there is it says one HSP, which is nothing but our Hedvig storage proxy component. So we have 2-tier architecture in which there is a storage backend, and then there's the proxy layer, which sits closer to the your compute applications or compute layer. And there's the one which is talking to your backup applications and translating these storage protocols like block or NFS or object storage to something that Hedvig understands. And yeah, these are, in fact, as you can see, a little hybrid in terms of capacity. These Azure nodes are, let's say, 1.2 terabytes, and these on-prem storage nodes are just 60 gigs. And again, this is not something that we generally recommend. This is just for this demo purpose that I built this cluster, and it's completely virtualized cluster. In fact, this Azure nodes are, of course, running Azure virtual machines, and it has storage assigned to it, and this whole instance becomes a virtual storage instance. And even on-prem, all of these storage nodes are deployed as VMs on VMware ESX host, and I've carved out some disk from a local data store and assigned to each of these virtual these VMs and made them a local or a virtualized storage instance. So this entire cluster pretty much is a virtual Hedvig cluster, but it is managing some capacity. The idea is to showcase how what problem we can solve with using Veeam. So going forward, each one of them have one storage proxy each, and I can show you. This is the VMware ESX I was talking about. This is where these on-prem storage nodes are hosted: Rover 1, 2, and 3, just as pure VMs. And this is the Azure. These are the Azure instances located as Azure virtual machines. Azure Dave Node 1, Node 2, and Node 3 are the 3 storage nodes that I'll be using for this demo. And this is the VM that I'll be backing up using Veeam. So test-win-esx-55y-1. So there's just one of our internal VMs that I stole from one of the users. I hope no one gets angry with this, just for this demo purpose. So what I'm doing here is creating a file inside this VM and just writing some test data in it so that when I restore it in Azure, I know it has worked. So the goal of this exercise or this demo is to back up a VM, and this is a Windows-based VM that I'll be backing up. I could have done Linux as well, because we can restore either Linux or Windows directly to Azure. But as part of this exercise, I'm just backing up a Windows VM, and I just created this file, as you can see in the screen, and wrote some data to it so that I know it has recovered properly. So this is the file that I created. So now let's start with the actual Hedvig volumes. So what I'll be doing is I'll create a shared volume. I can name Veeam backup disk, give it a size. Disk type would be NFS, and this is the optional backup option that I was talking about that you want to turn on when you're using Hedvig as backup target, and which optimizes these backup and restore operations. And when it comes to picking data centers, as you can see, you get an option of picking where the blocks of all the data that you write in this volume, Hedvig volume, should reside. And since this is a dual data center installation, you get these 2 options of whether you want your data to reside in Azure or in SNC1, which is nothing but your on-prem data center. I'll be selecting both of them because the goal is to back up this Windows VM on-prem and restore in cloud. And I'll show you how I'll do it without even installing a third-party tool or making an explicit copy of the data. Just by creating a volume which is data center aware, and you pick both the data centers, in this case Azure and SNC1, so there are 2 copies of data, one of them on-prem, another one on Azure. So as and when you're writing the data, Hedvig will make sure your data is replicated to the other location as well. so that when you actually go to the second data center, or in this case Azure cloud, the data will already exist there, and so you can restore from cloud without without calling any third-party APIs, without calling any explicit copy operation, or even without calling anything in Hedvig. So just by creating this volume as DC aware or data center aware, you have enabled this replication across from on-prem to cloud. So this is how you create a volume which is data center aware. The second step is to manage this export, which means assign this export using our Hedvig storage proxy so that it can be consumed by Veeam. So what I'll do is I'll use these storage proxies. So there is one storage proxy each in Azure as well as on-prem. So I'll assign this shared volume to both of them, so that this volume is accessible on-prem as well as in the cloud. And so one more thing that I can show you, in fact, is the resize option. But before that, in fact, this is doing is mounting the volume that we just created to our on-prem proxy, which can be leveraged by Veeam. So this is rover CVM1 is my on-prem storage proxy, and I just mounted the volume that I created to this local storage proxy, and I'll do the exact same thing in the virtual machine or the storage proxy, which is essentially running as a virtual machine in Azure. So after these steps are done, the exact same volume will be visible to Veeam on-prem as well as on cloud. In fact, I haven't mentioned, but what I've already done is I'm running Veeam backup application, backup and replication application on-prem as well as Azure as virtual machines too. So this is my Veeam, which is running on-prem. So as you can see, what I'm doing right now is creating a backup repository using the shared volume that I just created. And my storage proxy was nothing but a Linux VM, so I'm creating or accessing using a Linux repository, Linux backup repository. So all I need is the host name, which I'd use for exporting the shared volume. And once I provide that, if you just follow the Veeam steps, just provide the root and just a Linux account, and it should be able to access the volumes mounted to this Linux repository, and we should be able to see the volume that we had just created. So just give it a few seconds. So now you can browse our /mnp/ that on-prem volume that we had mounted on the local proxy. So this is the backup repository that we'll use for backing up our Windows VM locally. So as you can see, once you pop it, it will show you the size that I used while creating this volume, which was 100 gigs. So let's say you're running out of space. You created this backup repository. You're backing a bunch of VMs, but now it's crossing 100 gigs, and you want to expand it. It's as trivial as just going back to Hedvig UI and resizing this volume. And I can show you quickly. So there is a resize option that we have in the UI. So right now, from 100 gigs, I just made it 1,000, almost close to 1 terabyte, and just click run. And then you can simply go back to the Veeam UI and just open your backup repository that we just created, and just refresh its size, and it should be able to see the new resize option that we had just done. And there's no you don't have to mount or unmount anything. Once you're done resizing, it's just automatically visible. So you can literally on demand expand this volume as and when needed, and it's ready to be consumed as a backup repository now. So what we'll do is we'll do exactly the same thing for our Azure instance as well. So this is the Veeam instance that's running in Azure, and I'll follow exactly the same steps that I've done for my local repository. So I'll use my Azure-based Linux proxy for mounting this shared volume. And remember, this is exactly the same volume that's visible on-prem as well as in Azure Cloud, and which is being used as a backup repository at both places. So we'll follow the same steps. I should be able to see our Azure mounted volume /int/ Veeam Azure disk. And once this populates, you should be able to see the new size as well, which is 1000 gigs. I've set everything else to default just for the demo purposes, but of course there are a lot of other options that could be changed based on what your requirements are. But for this demo purpose, I haven't touched any of those. So this part is done as well. See, now we have both the backup repository created using the exact same shared volume on-prem as well as in the cloud. So now what we can do is we can go ahead and back up our Windows VM that we had modified. So we'll create this backup job, and all it will do is back up that test Windows VM that I was using, in which I created that test file, so that I know that I restored it correctly. So I'll use my on-prem backup repository for backing this VM, and in fact, this was one of the reasons I had to record this, because of course this takes some time, and I don't want anyone to keep just looking at the progress bar. So I've started this backup job, and in few seconds it will show you completed, because I've jumped over the part. And as I mentioned earlier, this is not the recommended installation, so don't look at or don't worry about the throughput numbers or the time taken. All of this will be way worse than what it's supposed to be because of the way I've deployed this cluster, which is not the optimal way. So this part is done. So this backup job is done on-prem, which means our Windows VM is backed up on-prem. So now I'm importing exactly same backup in Azure by using the backup repository that I created using the shared volume. And you will see that since it's exactly the same volume, obviously the same data that we wrote on-prem is visible in Azure as well. So the folder shows up, the files that were backed up on-prem shows up, so we can use that file to import it. And once that step is done, the second step is to restore it to Azure, which Veeam provides an option to directly restore to Azure, as you will see in the next step. So the bottom step, which is restore to Microsoft Azure. And again, for timing, for the sake of timing, I've provided all these options already. So I've set up my Azure resources already in this using this Veeam installation, so that it's all picking up all the default option that I had already provided, so that I don't have to pick and choose every time. So it's picking up all these Azure options, and it gives Veeam asks for this option. If I was backing up a Linux VM, I would have to do that step because of course Veeam allows you to restore both the Linux and Windows-based VMs. But in this case, it's just a Windows-based VM, so I don't have to do anything else. So everything I'm selecting default, not optimizing anything. And once you click finish, you will see in these next set of steps that it fetches all the information from the backed up file, which was backed up on-prem, visible in Azure, and leverages the exact same file for restoring this Windows-based VM. And now I'm in this Azure UI or Azure interface, and looking up the VM that I had backed up on-prem, and as you can see, the exact same VM with the exact same name has shown up in Azure as well. It just got deployed by Veeam. And I had already booted up my Windows VM, so you will see this activity which shows that this VM has actually booted up and hopefully working. And so the next step is to verify our file that we had created on-prem. Just to verify the size, it was around 40 gigs is what it showed up here as well. So I'll just connect using RDP session to this Windows machine in Azure, and let's see if our file showed up. And there it is. So this is the file that I created, and let's just verify the data still exists. And if you remember that, that's what I had typed in that file. So this uh, this is the capability that I want to show in this demo, that you don't need any other tool to make this work. When all you want to materialize is, you should be able to back up from anywhere and restore anywhere. As long as the backup application supports this capability, the storage layer, which is Hedvig, can take care of replicating data from one location to another seamlessly without without you interfering with or tuning anything. And not just that, in fact, let's say tomorrow you realize that I'm backing up from on-prem to Azure, but I want to restore in AWS or Google Cloud, where I had not actually made any copies of the data. Hedvig storage can dynamically, you can add more storage instances, let's say in AWS and Google Cloud, and make it part of your existing Hedvig storage cluster, which was on-prem and Azure. And Hedvig will know that the data resides in Azure as well as on-prem, and it will find, based on the latencies, based on the performance of the storage node, what is the best location to read the data from. So even though you did not even make any copy, for example, in AWS, still you can restore directly in AWS or Google Cloud, because Hedvig exists as part of a distributed cluster, and Hedvig knows where the data actually resides, and it redirects based on what volume or what VM you're trying to restore. So you could have mounted the exactly same shared volume in AWS as well, and Hedvig would know the data exists in Azure or on-prem, and it will pick one of those locations based on the performance and just fetch the data and enable your restore process. So you don't have to kind of come up with these complex backup workflows. All of that could be seamlessly taken care of by the storage layer, which is Hedvig, because it's location agnostic. It's cloud agnostic. You can have multiple data centers, multiple clouds, all part of the same cluster, and all you need to care about is during volume creation where the data should reside. And even though during volume creation you don't specify where it's accessible, of course you can change it later, so that let's say when you create AWS nodes, you can give access to AWS proxy storage, Hedvig storage proxy, and make your AWS instances visible to this shared volume and start the restore process. So this is one of the things that can be easily achieved by Hedvig and Veeam combination, which is very unique because of the way Hedvig works and can be deployed across different locations.